students, in today's lecture I am going to start a new topic, that is 8086 microprocessor. So in the year 1978, Intel came out with the 8086 microprocessor, which is a 16-bit microprocessor implemented in N-channel depletion load silicon gate technology, that is HMOS technology, and packaged in a 40-pin dual inline package. So starting with the features of 8086 microprocessor, it is a 16-bit microprocessor. The term 16-bit means that its arithmetic logic unit, internal registers, and most of its instructions are designed to work with 16-bit binary words. Second point, it has a 20-bit address bus and can access up to 2 to the power 20 memory locations, that is 1 MB. So yes, each of this 2 to the power 20 memory locations, which come out to be 1 MB, 220 memory locations mean 1 MB. So each of the 1 MB memory locations is 1 byte wide. Therefore, a 16-bit words are stored in 2 consecutive memory locations. Third point, it provides 14 16-bit registers. Obviously it has 14 registers and each registers are of 16 bit wide. Next point is the word size is 16 bits. 8086 has a 16-bit data bus, so it can read data from or write data to memory and ports either 16 bits or 8 bits at a time. Next point is 8086 has multiplexed address and data bus, which reduces the number of pins needed but does slow down the transfer of data. That is a drawback. Next point is it requires single phase clock with 33% duty cycle to provide optimized internal timing. The next feature of 8086 microprocessor is the Intel 8086 is designed to operate in 2 modes, that is the minimum mode and the maximum mode. When only one 8086 CPU is to be used in a microcomputer system, the 8086 is used in the minimum mode of operation. In this mode, CPU issues the control signals required by memory and input-output devices. In multiprocessor, that is more than one processor in the system, 8086 operates in maximum mode. That is, in maximum mode, control signals are generated with the help of external bus controller. Next feature of 8086 microprocessor is, that is an interesting feature that it fetches up to 6 instruction bytes from memory, and queue stores them, that is instruction queue stores them in order to speed up instruction execution. It requires plus 5 volt power supply. As I've already told you that it is a 40-pin dual inline package. The 1 MB address ranges from 00000H to FFFFH, and memory is byte addressable. Every byte has a separate address. As I've told you that each memory is of 1 byte. Now coming to the internal 8086 internal architecture. So the 8086 the internal architecture is it is internally divided into 2 separate functional units. These are the bus interface unit, this is the bus interface unit, and the execution unit. These two functional units can work simultaneously to increase system speed and hence the throughput. What is throughput? Throughput is a measure of number of instructions executed per unit time. So coming to the this is the bus interface unit. Coming to the bus interface unit, as you can see, this bus interface unit contains the instruction queue, which I've already told you that instruction queue is used for storing the prefetched instructions. So it contains instruction queue, it contains segment registers, and it contains instruction pointers, etc. So the bus interface unit in the 8086 interface is basically the 8086 interface to the outside world. It provides a full 16-bit bidirectional data bus and 20-bit address bus. The bus interface unit is responsible for performing all external bus operations. So what are the functions of bus interface unit? These are: it sends address of the memory or input output, it fetches instruction from memory, it reads data from memory or port, it writes data into port or memory, it supports instruction queuing, it provides the address relocation facility. So the next functional unit is execution unit. As I've told till now, I've told you about bus interface unit. The next is execution unit. So the execution unit, this is the execution unit. The execution unit of 8086 microprocessor tells the bus interface unit from where to fetch instructions or data. Then it decodes instructions and executes instructions. So execution unit is for decoding the instruction, executing the instruction, and telling the bus interface unit that is from where to fetch the instructions. So this bus interface unit and execution unit, if they work simultaneously, the system speed will increase. So there is a mechanism called pipelining. I will be explaining this term in detail in my later slide. So as I've told you that bus interface unit contains instruction queue, segment registers, instruction pointer, whereas the execution unit contains control circuitry, instruction decoder, arithmetic and logic unit. You can see here it contains arithmetic and logic unit, then it has flag register. The execution unit contains control circuitry, then it has instruction decoder, this is the control circuitry, then it has instruction decoder, then it has arithmetic and logic unit, it has flag register, then it has general purpose registers, pointer and index registers, etc. So going to the next slide, let's discuss the execution unit in detail. As I've told you that execution, what is the purpose of execution unit? It decodes the instruction fetched by bus interface unit. It executes the instructions and generate control signals. It tells bus interface unit from where to fetch the instructions. So the main parts I have already told you. What are the main parts? Like control circuitry, instruction decoder, and arithmetic and logic unit. As I've told you that the execution unit, as you can see from this slide also, that the execution unit consists of registers. It consists of general purpose register as well as pointer and index registers. So let's discuss in detail about the general purpose registers, then we'll go one by one at a time. So basically 8086 microprocessor has a powerful set of registers which include general purpose registers, segment registers, pointer and index registers and flag registers. So among these different classifications of registers, general purpose register, segment, pointer and index register and flag register. Again I am repeating, general purpose register, pointer and index register and flag register, they are present inside the execution unit, whereas segment registers are present inside the bus interface unit. So let's talk in detail about the general purpose register. 8086 has four 16-bit general purpose registers labeled as AX, BX, CX and DX. Each 16-bit general purpose register can be split into two 8-bit registers. The letter L and H specify the lower and higher bytes of a particular register. For example, BH means the higher byte of the BX register and BL means the lower byte of the BX register. The letter X is used to specify the complete 16-bit register. So these general purpose registers are either used for holding data, variables and intermediate results temporarily. They can also be used as a counter or used for storing offset address for some particular addressing modes. The register AX is used as 16-bit accumulator, whereas register AL is used as 8-bit accumulator. The register BX is also used as offset storage for generating physical addresses in case of certain addressing modes. On the other hand, the register CX is also used as default counter in case of string and loop instructions. So here I have written the purpose of these registers in detail. So the next registers are pointer and index registers. So all segment registers are 16-bit wide. I'll be discussing in detail about the segment registers. First, you just for understanding the pointer and index registers, you need to know that I've already told you that all the registers are 16-bit wide. So all the segment registers are 16-bit wide. But it is necessary to put 20-bit address on the address bus, as I have told you that the address bus is 20-bit wide in 8086 microprocessor. So it is necessary to put 20-bit address on the address bus. To get 20-bit physical address, one more register is associated with each segment register. So these additional registers belong to the pointer and index group. The pointer and index group consists of instruction pointer, stack pointer, base pointer, source index and destination index registers. So starting with the stack pointer. So the stack pointer register contains the 16-bit offset from the start of the segment to the top of the stack. For stack operation, physical address is produced by adding the contents of stack pointer register to the segment base address in stack segment. And to do this, the content of stack segment register are shifted 4 bits left and the content of stack pointer are added to the shifted result. Next is base pointer. So the base pointer can be used instead of stack pointer for accessing the stack using the based addressing mode. So there is an addressing mode, that is based addressing mode. So using that based addressing mode, base pointer register can be used instead of stack pointer for accessing the stack. In this case, the 20-bit physical stack address is calculated from base pointer and stack segment. The next is source index register. So the source index can be used to hold the offset of a data word in the data segment. In this case, the 20-bit physical data address is calculated from source index and data segment. And the last one is destination index. Here the extra segment register points to the extra segment in which data is stored. String instructions always use extra segment and destination index to determine the 20-bit physical address for the destination. I am ending this class here. In my next lecture, I'll be discussing here, while discussing the pointer and index registers, I've named various segment registers. So I'll be discussing in detail about the segment registers in my next lecture. Thank you.